Hi, welcome back. Monty here, and we are now in Module 5, Topic 1, and it's called Probability. Think of it as decks of cards, rolling dice, and what's the probability of picking a certain type of donut or a certain type of potato chip? All right, we're almost done with the year. Let's get started. Okay, so determine probabilities. What's the probability of an event happening? Okay, what's the probability of everyone in our class having a yellow vest on? Okay, here we go. Okay, what are the chances? A probability of a number between 0 and 1 that measures the likelihood of given an event will occur. The number of outcomes, total, and the number of favorable outcomes. Okay, so impossible, absolutely, somewhere in between. Okay, so drag each event and indicate the most appropriate probability. It will snow in Arizona, 0. The next baby born in the local hospital will be a boy, half. Why was that? Flipping a coin, landing on heads, half. Oop, how'd that happen? The sun will shine in Long Beach, California in July, most of the time. Wow. Rolling a standard 6-side number cube and rolling an integer. Okay. So I should grab some of these so that we have them to talk about, right? An integer, 1 through 6. Absolutely going to happen all the time. Draw a red card out of a deck. Well, half of them are red, half of them are black. You live to be over 100. That's not going to happen. All right? Cool. Okay, white t-shirt. Okay, so we have, the drawer contains 8 white t-shirts, 5 red, 6 green, and 1 purple. Okay, so a white t-shirt, 8 total. So a white t-shirt, 2 white. Let's shrink this down a little bit. And bring that over a little bit. 4 different colors. 8 white, 5, 6, 1. 8, so 19, 20. 20 of them. 8 out of 20. Okay, 8 out of 20. Simplified. So a green t-shirt. Green. 6. 6 out of 20. 6/20. Okay. Purple. 1 purple. 1 out of 20. The sum of the probabilities of the model. The sum of the probabilities is 20 out of 20. Okay, the probability that a t-shirt is not purple, 19 of the 20. Orange. Orange. There is no orange. Not orange. None of them are orange, so it's 100%. Okay. Alright, now we got our spinner. Now, the outcome is a white, 1 out of 5. 1 out of 5. Yellows, 2 out of 5. Blue, 2 out of 5. The sum of the probabilities is all of them added up. The sum of the probabilities is always the same because the sum of the probabilities includes each possible. Determine the additional probability that the spinner for the event spinner spin the spinner 1 time. What is the probability of the complement landing on a blue? Determine each probability for the event spin spinner 1 time. Complement. So the other part. So landing on a blue is 2 out of 5, so that's everything else. Okay. probability of landing on yellow and blue. Put them together. So there's 4 of the 5. This is the probability of landing on yellow or a blue. Probably the intersection that is both yellow and blue. Well, there's none of them then. Okay, you can't have both. Okay. And statements or statements. And statements or statements. Yellow or a blue. So there's the 4 of the 5. So I did them backwards. My bad. All right. Picking from a card. Draw a picture from a deck of 46 cards. Each card then contains a shape. The shape of the cards are diamonds, rectangles, and stars. So diamonds, 1, 2, 3, 4, 5, 6, 7, 8 of the 46. 8 of the 46. Rectangles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19 of the 46. A circle, 3, 6, 8. 8 of the 46. Stars, 11 of the 46. Not a star, so got to get rid of 11. So 35. Actually, 46 minus the 11. Divided by, let's get back out of here. Okay, so parenthesis, if you're not sure, just go 46 minus 11 divided by the 46. Rectangle or a circle, so we're going to add them together. Rectangles, 19, circles, 8 on the outside, slash the 46. Could be those or this. These are all ors, star or diamond. Star is 11, diamond 8, outside, divide by 46. This and that, you can't have them at the same time. Okay, so an and statement means there has to be overlap, and there was no overlap here. Okay? Alright, Java. Javier spins the spinner all in the same size. The probability of spinning a 7 is 1 out of 6. 30 times. How many would you expect? 1 out of 6. How many 7s would you expect to spin? 30 out of 30. Okay. Cool. Enter all the probabilities. Probability of getting a 4 is 1 out of 6. Probability of a 5, don't see a 5. Probability of a letter is 2 out of 6. Oh, 3. There's 3 letters. My bad. Odd numbers. 1. Less than 5. 2 and 4. Analyze the example. Suppose Javier were to spin the 180 times. Is there any spinning that Javier would land on an even number? So there's 2 over 180. Cross multiply, so we get 2 times the 180. Now we have to divide by 6. So 60 of them. So 180 times determine expected Javier would land on a letter. 1, 2, 3. Now don't mess this up. 3 of the 180. So 3 times 180. Divide by 6. 540 divided by 6 is 90. He would not expect he would not expect predictions. He would not expect to get the results of his calculations. The above calculations are strictly predictions. That's cool. Alright, probability of event. 45 coaches, 20 of them require daily batting practice from their players. What is the probability of the percent that the next coach your neighbor surveys requires the batter? So 20 of the 45. To solve this problem, set it up. 44%. Oh, yeah, 44% of the time. Okay, so must fulfill 50 hours of community service. She takes a survey of parents who attend her information center. One of the 44 parents, 27 think the requirement is a good idea. So 27 of the 44, no. 27 of the 44, and we multiply by 100, so we get 27 times 100 equals 44p. 44p divided by 44 to get how many we're expected. 61.36% of the time. Now remember, that means you multiply by 100, right? To get the percent, divide, multiply, right? Okay. All right, if there are 100 per survey, approximately 61 of them. If 1,100 parents are at the school, how many would she expect? Well, it's still 27, 44, 27 times 1,100, 44, 29,744 divided by the 44. 29,700 over the 44 to expect 675 parents to choose. Okay, probability. Okay, 45 coaches, 20 of them, probability of an event. What is the probability that the next coach survey and practice? To solve this, we will use this proportion. Okay, so now your sample includes 98 ants, 19 of them are red. What's the probability of the next ant to attack will be a red ant? So 19 of the 98, and here we have 19 times 100. We have 98. Now we just divide out the 98, and that percent is 19.39%. 300 ants, so we have the same 19 over 98. 19 times the 300. We have 98 of them, so now we divide it out. And we would expect 58 of the next ants to be there. Okay, probability of an event. Let's see what's next before we stop. Okay, so that finished the first unit.